What number?
I did.
Okay, what number?
I know that it was one of the first ones, and I tried to get my, because I'm in the math place for learning that because the one that I was in was too cool.
Right.
So she helped me on it, but I was still kind of confused about it.
Okay.
Okay, here it is. I think it was question 11.
Okay. What? And can you read the problem to me?
It was x plus y equals 0 and x minus, no wait, that wasn't it. Okay, it was 5x plus 2y equals 9, and then x plus y equals -3. And I was confused on the 5x plus 2y equals 9, like I forgot how to do it.
Okay. So what number is this? It's not 11. It's 13. Okay. So number 13. What you want to do, the very first thing that you want to do is decide if it's easier to solve for x or y and in which equation, okay? If I picked the top x, then I would end up having to divide by 5. So I would have 2 over 5 and 9 over 5. So I don't really want to do that if I don't have to, okay? If I picked the top y, I'd end up having to divide by 2. So I'd have 5 over 2 and 9 over 2. Again, I would get the right answer, but it's going to be more complicated, so I would not choose that if I didn't have to. So what I'm going to do is I'm going to solve either for this x or this y because I don't have to divide by anything because the coefficient is a 1. Okay? So if I use this equation, Allie, did you solve for x or y? Which one did you get by itself?
I got y equals x minus 3.
Okay, that's a problem. Y equals, if you subtract x from both sides, it should be negative x minus 3. Okay? So now, because you know what y is equal to negative x minus 3, so you could put that into the other equation for y. Those are equal. So everything else stays the same. I'm just going to have 5x plus 2 times, take the y out, put negative x minus 3 in, equals 9. So now, if you look at this problem and you still have an x and a y in the equation, you have plugged in wrong. Okay, so reevaluate how you plugged in. But if not, you can go ahead and distribute and solve. So 5x minus 2x minus 6 equals 9. Combine like terms here and we get 3x equals, I'm going to add 6 to both sides, and I get 15. So when we divide, we get x equals 5. So that helps us with the x. Now we need y. Well, we know that y equals negative x minus 3. So if we take x, which is 5, and plug it in, we get y equals negative 5 minus 3. Whoops, here we go. And so that's y equals negative 8 because negative 5 plus a negative 3. So if you write it as a coordinate, you have 5 comma negative 8. Questions on that one? Okay, what other problem do we need to see? Yep.
Number
15.
15.
All right. 15, let's pick red, I don't know. Can you read the problem, please?
It's 11x minus 7y equals 9. And x minus 2y.
Okay, so for this one, the variable that I would get by itself is the x on the bottom, because here I would have to divide by 11, here I'd have to divide by negative 7, and here I'd have to divide by negative 2. But if I pick the x on the bottom, I don't have to divide by anything. Okay? So if I add 2y to both sides, this becomes x equals 2y minus 4. So now that x equals that, I can take the 2y minus 4 and plug it in for x. So nothing in that equation is going to change except for I'm going to take the x out and I'm going to put 2y minus 4 in. So we'll have 11 times 2y minus 4 minus 7y equals negative 14. Notice I plugged it in parentheses because that 11 has to go to both pieces of it. Okay? So when we distribute, we get 22y minus 44 minus 7y equals negative 14. So let's combine like terms here. We have 22y minus 7y would give us 15y. Equals, I'm going to add 44 to both sides. So we get 30. And divide by 15, you get y equals 2. So half of our problem is done here now, okay? If y equals 2, we can plug that back in, and we can find x, because x is going to equal 2 times whatever y is, and we know that that's 2, minus 4. So we've got 2 times 2 is 4, minus 4 is 0. So we've got 0, too. Any other problems you guys need to see? Good to go? Okay.